Hi everybody, hope you're doing well. This lesson is going to finally dive into some new material that you haven't learned in the previous math class, and it's going to build off of stuff that we've gone over here in the last three lessons. This is going to finally discuss how we factor polynomials. This is something that's going to be pretty much the focus of what we do the rest of the school year because there's a lot of different components and a lot of different strategies that deal with this concept of factoring. This is also something you're going to very heavily see as you move forward. Algebra 2, this is a skill you use all the time. You go further into pre-calculus, it's a skill you're going to use over and over again. So we're going to really spell out here over the next few weeks how to factor apart polynomials, how we break them down. So for today, what we're going to first look at is how to factor out a greatest common factor, a GCF. So this is going to build off of the previous lesson where we reviewed how to find least common multiples in GCFs. We're going to focus on the GCF part again here today. So what is factoring? Factoring is basically how you undo distribution. So a couple lessons back, we went over how to multiply polynomials, so we were distributing terms together. Well, we can undo that by this factoring process. So distribution, you take a couple polynomials, you multiply them together. If I have one big polynomial, some of them will break apart into those separate, smaller polynomials. That's what factoring is. So again, we're going to focus on how to factor out a greatest common factor in this video. In future lessons, you're going to learn a whole bunch of other factoring strategies, and we'll talk about when to recognize what to do and all those sorts of things as we get to them. So let's talk about how we factor out a GCF in each of the six problems you see on the screen. Once we go through about two or three of these, if you want to hit the pause button, try the next couple and see if your answers line up. I certainly recommend that to see if you're comprehending what we're doing here. If you're struggling to find the different patterns of what I'm doing, obviously, if you continue to hit play, all my explanations will be there for all the problems you see in this lesson. So let's start with number one here. We have 5x squared minus 20x. In order to factor out a GCF, we need to think of what is the greatest thing I can divide out of all the terms given. So if you recall in the last video, when we talked about finding GCFs, I made a lot of factor trees, which were great because we were just finding GCF. There really wasn't any context to it. But I did make reference multiple times that as we move forward, especially with factoring, it's going to be a lot easier to find GCFs. Well, not so much easier, but in terms of showing workout and making it more organized, if you can find the GCFs in your head rather than making factor trees all the time, it'll be a lot easier to show your work, because as we move forward here, we're going to emphasize that factoring process quite a bit. And you'll see with the way that I lay the workout how we can keep it organized. But ultimately, you're going to see a lot of the same number patterns over and over again. So the more that you try to practice doing these in your head and seeing if they match up, the easier it'll be to show all of your work. So let's talk about 5x squared minus 20x. We've got two terms, 5x squared and minus 20x. What we want to figure out is what's the biggest thing that will divide out of both of those terms at the same time. So when we find GCFs, sometimes we're just taking out numbers, sometimes it's just taking out a variable, sometimes it's both. Let's first look at the 5 and the 20. The biggest number I can divide out of 5 and 20 is a 5. So I'm going to take that out, write that down first. Then we're going to look at the x squared and the x. If you recall from the previous lesson about GCFs, the greatest thing you can divide out is essentially the lower power of your variables. So if I have an x squared and an x, the most I can take out is an x. So the GCF of my two terms is 5x. Since we're doing this factoring concept, we are also not only going to show the GCF, but we're also going to show what would be left over. So to show what's left over, as soon as I write my GCF, I'm going to open up a set of parentheses. And what I'm going to do is take that 5x that I factored out. To factor something out means I'm dividing it out. So I'm going to divide that 5x away from the 5x squared. 5 divided by 5 is 1, so I'm not going to write that. X squared divided by x means I have an x left over. Now I'm going to take negative 20x divided by 5x. Negative 20 divided by 5 is negative 4. X divided by x cancels out. Once I've shown what happens when I divide out that factor, I close my parentheses, and I'm done. So 5x squared minus 20 factored apart has a GCF of 5x with a leftover polynomial of x minus 4. Now, the way that I can check to see that I did that right, now again, you don't have to show this check by any means. The way that you check to see if this math makes sense, again, factoring and distribution are opposite operations. So if I factor something apart, you can distribute it back together to see, hey, did I actually do this right? So if I do a really quick check, 5x times x is 5x squared. 5x times negative 4 is negative 20x. It matches my original problem, so that will tell you that you factored it correctly. Again, you don't need to show that, but that's just the way to connect so you can see how distribution and factoring are just opposite operations of each other. So, that's what we're going to be taking a look at here in all these different examples. It's all going to be that same process to factor the GCF. What's the biggest thing I can divide out, both in terms of its numbers and its variables, and then write what's left over. So number 2, I see 12x squared minus 6x. First thing I want to do is, what's the biggest number I can divide out of 12 and negative 6? The biggest number I can take out is a 6. X squared and x, again, lower of the x values is the most I can take out, so I can take an x out. My GCF of these terms would be 6x. Once I write my GCF, I open up that set of parentheses and divide the 6x away from each term. So 12x squared divided by 6x, 12 divided by 6 is 2, x squared divided by x is x. Negative 6x divided by 6x. Negative 6 divided by 6 is negative 1. X divided by x cancels out. And I have my final answer. 6x times the leftovers, 2x minus 1. Whenever you factor out a GCF, so you notice we have a 1 that was left over, it doesn't matter if it's negative or positive. You always have to have, in that parentheses where your leftovers are, the same amount of terms that you started with. So if my original problem has 2 terms, that means when I have my set of parentheses with the leftovers, I should see 2 terms there. So that's more just to keep in mind. If when you divide out a GCF, you're left with just the 1, you have to put that 1 in as a placeholder. You can't just leave it blank or ignore it altogether. We use the same process no matter how many terms we have. So you'll see in numbers 3 and 4, we've got 3 terms each. 5 and 6, we've got a mixture of some different variables, but again, it's all the same idea. So number 3, again, I need the GCF of all the terms, so I need the same thing to divide out of everything. So numbers-wise, I have 2, negative 16, and 24. I can take a 2 out of all 3 of those numbers. I have an x squared and x. My last term has no variable. What that means is I cannot take an x out as part of my GCF because they all do not have variables. So my GCF is just 2. I open up my parentheses. I'm going to divide each term by 2. So 2x squared divided by 2 is just x squared. Negative 16x divided by 2, negative 8x. 24 divided by 2, positive 12. And that is my final factoring. Number 4, same idea. What's the biggest number I can divide out of 12, 8, and 24? Negative 24, technically. The biggest number I can divide out is a 4. Variables, I see an x cubed, an x squared, and an x. They all at least have an x. That means I can take an x out of everything. Again, that's the lowest power of the 3. So that would be the most I can take out of all 3 x terms at the same time. So my GCF would be 4x. Divide that away from each of the terms. So 12x cubed divided by 4x. 12 divided by 4 is 3. X cubed divided by x leaves me with x squared. Now I have 8x squared divided by 4x. 8 divided by 4 is positive 2. X squared divided by x has an x left over. Negative 24x divided by 4x. Negative 24 divided by 4 is negative 6. X divided by x cancels. So here I got my final answer. 4x times 3x squared plus 2x minus 6. That is my factored answer. Number 5, same idea. We're back to 2 terms. So again, looking at 10 and negative 35. The biggest thing I can take out is a 5, numbers-wise that is. Now variables, so I see multiple variables. We do the same thing. I'm going to look at the x's, and then we'll look at the y's. So I have an x squared and an x. The most I can take out is the lower power, which is the x. And now I'm going to look at the y's. I have a y cubed and the y squared. Take out the lower of the y's. I can take out the y squared. My GCF is 5xy squared. Now we open up our parentheses. We divide away just like we did in the other 4 examples. So 10 divided by 5 is 2. X squared divided by x is x. Y cubed divided by y squared is y. Negative 35 divided by 5, negative 7. X divided by x cancels. Y squared divided by y squared cancels. So I've got my final answer, 5xy squared times the leftovers, 2xy minus 7. Last but not least, here on this slide, we've got 24x squared y plus 18x. Biggest number I can divide out of 24 and 18 is 6. I have an x squared and an x. That means I can take an x out of each. I have a y, and I have no y in the second term. That means I can't take anything out in regard to the y's because there's no y in the second term. So my GCF of the 2 terms given is 6x. Now we divide. 24 divided by 6 is 4. X squared divided by x is x. Y divided by, there's nothing to compare it with, so it's just y. 18 divided by 6 is 3. X divided by x cancels. You're left with 6x times 4xy plus 3. So in general, that's how you factor out a greatest common factor. You're looking for the greatest amount that you can divide, both numerically and in terms of the variables, out of all the terms at the same time. And then you're actually showing that division, putting in parentheses what is left over. Another quick note about factoring out a GCF, there are some problems where sometimes you can take out other numbers that might be lower than the greatest common factor. You could take out a common factor rather than the greatest common factor and still have something that breaks down. However, when you look in the parentheses with the leftovers, there should be nothing else that you can take out. If you look at all 6 examples, if I look in the sets of parentheses, there's no other thing that I can divide out. That tells me that's as far as it goes. If you don't take out the greatest factor, sometimes it'll look like there's more you can divide out. That just means you didn't take out the biggest number or the greatest variable possible. So again, most of the time they'll probably be pretty easy to pick up, but again, depending on your mental math, you just want to check and make sure that you are indeed, especially with the numbers, taking out the greatest amount possible from everything. So the one other little caveat that you'll notice with this, and this is something that will be more important as we get further along in our factoring strategies over the next few weeks. If you look back at problems 1 through 6, if you look at all 6 of the problems, they all started with positive terms. So at least led with a positive term. So 5, 12, 2, another 12, 10, and 24. That's not always the case. Sometimes they are led with negative terms. Okay, so you can see here numbers 7 and 8, the leading coefficients are negative. Not a big deal. All you have to do is this, and it's a little detail that at this stage it doesn't look like it makes a huge difference, but again, when you learn some other strategies down the road here, this will help immensely. If you have a leading coefficient that's negative when it comes to factoring, you want to take the negative side out with whatever your GCF is. So in effect, you want to basically take that negative out and flip all the signs of the terms that are in your original polynomial. Again, this will be more helpful down the road, and I'll explain more why when we get there in a couple of weeks. So we're still going to do the same thing that we were doing in the previous 6 problems. The only difference is we see a negative out front. It's just going to come with our GCF. So number 7, again, I want the greatest number I can divide out of all 3 of those terms. I can take a 2 out. And the greatest amount of x's, again, I see x fourth, x cubed, x squared. The lowest power is an x squared. Now, since my leading coefficient is negative, I'm going to take the negative out with it. And I'm going to have a negative 2x squared out front. So that means when you divide it away, be conscious of that negative because it is going to flip all the signs when you go through and divide. So negative 8x to the 4th divided by negative 2x squared. Negative 8 over negative 2 would be 4. X to the 4th divided by x squared is x squared. 14x cubed divided by negative 2x squared. 14 divided by negative 2 is negative 7. X cubed divided by x squared is just x. And then 6x squared divided by negative 2x squared, 6 divided by negative 2 is negative 3. X squared divided by x squared cancels, so there's nothing there. And here you have your factored expression. Same deal in number 8, negative 21x cubed minus 28x. Take out the biggest number you can of each term. 7 is the greatest number that will divide out. You have an x cubed and an x. X is the lower of the two powers. That's what you can take out. My leading coefficient is negative, so I'm going to take out a negative with my 7x. Open up my parentheses and do the same division. Negative 21 divided by negative 7 is 3. X cubed divided by x is x squared. Negative 28 divided by negative 7 is positive 4. X divided by x cancels. And here we have our factored expression. So it is a little detail that seems kind of nitpicky at this point because there's not a lot of context to it, but you're going to learn other factoring strategies that'll break some of these problems down even further, and by not taking out that negative can make them harder to use those other strategies. And again, you'll learn those here over the next couple of weeks. So we'll finish this off here with a classic describe and correct. So I give you a problem, I factored it, I made a mistake. If you want to hit the pause button here for a second and try to figure this out in your head, that would be the good time. Otherwise, let's let this play through and I'll explain it for you. So, when they factored it out, let's look at the numbers. 30, 15, and 10. The biggest number you can take out is a 5. That's fine. That's not the issue. Look at your x's. You have x to the 8th, x to the 4th, x cubed. Look at what was taken out. It's just an x. That's your mistake. The error, the GCF is wrong. So they took out an x. Now, that in itself is not fully incorrect. It is a common factor, but I want the greatest common factor, which means I got to take out the most I can in one shot. So to fix it, I don't want to take out 5x. I want to take out 5x cubed. So what would be left over? Again, going back to the original problem, if I take out a 5x cubed, I'd have 6x to the 5th negative 3x and negative 2. Again, if I were to distribute that together with the incorrect answer or the correct one, I end up getting back to the same problem. But if I'm factoring out a GCF, and again, something that'll be more important as we learn more strategies and we do more than one thing at the same time, you want to make sure to take out the greatest amount you humanly can. So 5x cubed is a more appropriate thing to take out than 5x. So your final answer would be 5x cubed, parentheses 6x to the 5th, minus 3x minus 2. So that is how you factor an expression by taking out the greatest common factor. With this, the assignment that you'll do, so this actually has an IXL that ties really nicely to it. So your assignment that goes with this, again, so we'll go back to IXL. Now again, we're going to stray away from this here after this week. We'll do maybe 1 or 2 more as we go throughout the rest of the year, but we'll kind of lean off of this after this week. So for IXL, we stay in our level K. The topic that you'll want to do with this, AA2. And just like all the other IXLs, if you want your full points, you'll want to get it to an 80. So that's going to be your graded assignment for this lesson. If you have any specific questions, if you need some extra help, please do not hesitate to send me a Schoology message, shoot me an email, or we can set up a time on Zoom, and I can certainly walk through an infinite amount of examples until you understand how this works. This is the basis of this concept of factoring. So if this is something you're struggling with, please do reach out to me because we are going to continue to build on this over the next few weeks. This is a building block for it. So again, if you have any questions, please let me know. Otherwise, thanks for watching. We'll see you next time.